In this chapter, we're going to study trigonometry. In this lesson, we're going to introduce the sine law and use it to find a missing side.
Okay, hi everybody. So in this lesson here, we're going to take a look at something called the sine law. And we're going to use it in this lesson here just to determine a side of a triangle that we're not given. Okay? Now, this is a tool that I'm going to give you here. I'm not going to really explain where it comes from. I've got another lesson that actually does that develops the idea of the sine law. But really, right here, all we want to do is get some practice using the tool. Okay? So you take a look at your right angle triangle here, and the point is that this particular rule works for triangles that don't need to be right angle triangles, okay? They can be acute triangles, they can be obtuse triangles, it doesn't matter. The sine law works. But the sine law needs a very specific setup for it to work, okay? And here is the sine law. I'm going to zoom in for you right here. Okay, the sine law here basically says this, that there is a ratio that exists, or proportions that exist here. The length of little a, or side A, divided by the sine of angle A. Now, it has to be the sine of angle A. I've seen some people that after they use this for a little while here, they stop using the sine, and that's not correct. So the length of side A divided by the sine of angle A should equal the length of side B divided by the sine of angle B. That should also be equal to the length of side C divided by the sine of angle C. Okay, and that actually makes a bit of sense. We've talked about this before, that remember, in a triangle, the smallest angle opens up to the smallest side. There's a relationship there. The largest angle opens up to the largest side. Well, it turns out that the ratio of that side to the sine of the angle opposite is always the same in a triangle here. Now, over here, okay, here's our triangle. Just remember the way things are labeled here. Little b is opposite big B, little a is opposite little a, little c is opposite little c here. To use the sine law, okay, to use the sine law, I need to have one of these ratios completely, okay? If you don't, then you can't do it, which means you have to have little a and a, or you have to have little b and b, or you've got to have little c and c. Okay, you've got to have one of those pairs in order for this to be a sine law problem, or at least I have to be able to find that pair before this can be a sine law problem. Now, that being said, let's take a look at some examples of how you would use the sine law to figure out the length of the side, a missing side in a triangle. Okay, so for this problem here, we're told determine the length of side B. Okay, so for each of the two problems we're going to do right here, we're going to look for side B here. Well, in order to get side B, if I don't know side B, I must know angle B. Now, this was something that we hadn't actually mentioned when we were just introducing what the sine law was. I need to have a pair, an angle side pair, and in this case I do. I have A and I have little a. But before I can get little b here, I need to have the angle opposite it. Okay, so I need to have that pair complete. Now, it could have been little c and c. It doesn't matter what it is. I just need to have an angle and a side pair, and then I need to be able to find the angle opposite the side that I'm looking for. Now, it looks like this. So it's going to be little a, 18.9, divided by the sine of a, which is 63 degrees, and that is going to be equal to little b, which is what I'm looking for, over the sine of 75 degrees. Okay, now in a previous lesson here, when I was working with the sine and cosine and whatnot of angles, I would immediately put the values in there. I would go through my calculator and evaluate the sine of 63, the sine of 75. In this particular case here, I'm not going to do that. I want you to get used to manipulating these symbols and then plugging in those values afterwards. My goal is still the same. I'm still going to cross multiply. So this is going to end up being 18.9 multiplied by the sine of 75 degrees. And that is going to equal b multiplied by the sine of 63 degrees. Okay, so I took this, and I know that this is just a number. And my calculator knows what that number is. And so I can get it later on when I need it. But I'm going to multiply b by the sine of 63. I'm going to multiply 18.9 by the sine of 75. I am looking for b. So now I want to get rid of this. So now I'm going to divide that back over. So I'm going to get that 18.9 multiplied by the sine of 75 degrees divided by the sine of 63 degrees is going to equal b. Now I can go to my calculator and let's figure that out. So 18.9 multiplied by the sine of 75 degrees, and I want to make sure that I close the parentheses there, or else the calculator will think I'm doing something different. And then I'm going to divide by the sine of 63. And my answer, and I'll round this to the nearest tenth, is 20.5. Okay, so 20.5 centimeters is equal to B. Now, does that make sense? Well, the side opposite angle A is 18.9 and A is 63 degrees. B is a little bit bigger than that. And my side is actually a little bit bigger than that, so I'm okay. That makes sense. Yep, I'm happy with the way that looks. Now let's take a look at this question. Okay, once again, I'm looking for B, so I have to have angle B, and I do. Okay, now I don't know what this is that I've just been given. I haven't got a clue. I don't know if this is A or C or whatever. I know it's not B. So I tell you what, let's call it C here, just so that you get a sense of how this works here. So that means angle C is 75, little c is 17. This can be A. I don't even need A. A is not part of it. As long as I have got that pair, that angle side pair. So now I can set up the ratio here. I know that 17 divided by the sine of 75 degrees, that's the part that I'm given, is going to equal little b, what I'm looking for, over the sine of 61 degrees. Okay? So now I'm going to cross multiply and I'm going to write it out. So 17 times the sine of 61 degrees is going to equal b multiplied by the sine of 75 degrees. Now I want to get b by itself, so now I'm going to divide by the sine of 75. So this will be 17 multiplied by the sine of 61 degrees over the sine of 75 degrees is going to equal b. That's what I'm looking for. Now let's go to the calculator and we'll let the calculator finish up that work for us. So that will be 17, whoops, can't see that, 17 multiplied by the sine, okay, of 61, close the brackets there, close the parentheses, divided by the sine of 75, and we get 15.4. So 15.4 centimeters is equal to B. Now let's just see, does that make sense? So 17 is opposite 75. Now my angle gets a bit smaller here, and that's okay because my side also got a little bit smaller. So that's good. That seems consistent. I'm happy with that answer. Okay, so now in this question, it's the labeling is a little bit less specific here, and that's totally okay. It says determine the length of side X in the following diagram. Okay, well, to get side X, I need the angle opposite it, and I don't have that. I've got this angle and the side opposite it, which is great, but I don't know that angle. Now, fortunately, what I do know is I do know these two angles right here. And remember, if you know two angles in a triangle, then you automatically know the third one. You just have to find it. I know that the angles have to add up to 180. So if I take 180 and subtract 59 and then subtract 46, I'll get 75. Wow, 75 is coming up a lot in this. That's just accident. That wasn't on purpose. So this is going to be 75 degrees. So that's going to be 180 degrees minus 59 degrees minus 46 degrees. Yoink, is going to equal this angle right down there. Now, I'm going to set up my ratio here. So I was given 51 divided by the sine of 46. And I'm looking for x over the sine of 75 degrees. I'm going to cross multiply. So 51 multiplied by the sine of 75 degrees is going to equal x multiplied by the sine of 46 degrees. Okay, now I want to get x by itself. So x is being multiplied by this sine of 46. Remember, that's just a number. Don't get thrown off by the fact that there's a sign there. It's just a number. So this is going to be 51 multiplied by the sine of 75 degrees over the sine of 46 degrees is going to equal x. And then we again go to our calculator. Okay, so 51 multiplied by the sine of 75, close the parentheses, divided by the sine of 46. And I'm going to get to the nearest tenth here again, 68.5 centimeters. And now again, let's just double check that makes sense here. So 46 degrees opens up to 51. Well, that's 75. Well, 75 it's substantially larger than 46, and yeah, there's a bit of a jump here, right? Okay, that's a jump of 17.5. So yeah, that seems good. I like the fact that this is as much bigger than 51 as I would have kind of expected there based on how much that opens up. So that's good. I like that. Let's take a look at this next one. Again, still looking for x here, and again, it's the same problem. Okay, once again, I know this angle and I know the side opposite. But what I don't know is this angle right here. So that's the very first thing that I got to do. And I look at the total. I know that the total, I know that the total sum of the angles should be 180. And then I'm going to subtract from that 72 degrees and 54 degrees. Okay, so 180. Whoa, you can't see that. Minus 72 minus 54. Oh, well, that works out kind of nicely. This is going to be 54. So this is 54 degrees here. Okay, now we're going to use the sine law. So it's going to be 23.6 over the sine of 54 is going to equal x over the sine of 54 degrees. Okay? So now we're going to cross multiply and divide. So this is going to be 23.6 multiplied by the sine of 54 degrees is going to equal x multiplied by the sine of 54 degrees. Then I'm going to divide, and I'm going to get 23.6 multiplied by the sine of 54 degrees divided by the sine of 54 degrees. Now, if you haven't seen it already, maybe you're going to see it now. Well, wait a minute. Those two are the same. They're exactly the same. Shouldn't those have canceled? And yeah, they will. Now, you can go do this on your calculator. Your calculator will give you the exact same value here. But x is going to be 23.6 centimeters. And actually, that makes perfect sense because even though the triangle doesn't look like it, it's because I'm just using a stock triangle image here. Okay, this is actually an isosceles triangle. Okay, it's supposed to be because these two base angles are the same, and if those two angles are the same, that means these two sides are the same. So I could have actually jumped to that conclusion almost immediately in this problem, but the trigonometry here, the sine law, also confirms that that's what's going on. Okay, now we're going to take a look at this last question here, and actually this question is one of these questions that you're probably going to get a lot on assessments here because it's a good question. It requires both the sine law and then just regular old trigonometry, your SOHCAHTOA to make it work here, because what we've got here is a triangle that's not a right angle triangle, and then it's connected to one that is a right angle triangle. So this one right here just requires basic trigonometry. Now, I want to figure out what h is, but in this triangle, I've only been given the two angles. That's not enough information to figure out what h is from this triangle. But for this triangle right here, I actually do have enough information. I got to find it though. I know that this angle here is 50, and I know that this length right here is 7.6. Now, this angle here is 65 degrees, but that means I can figure out what this angle is on this side because when these two are added together, they should be 180. Okay? So 180 minus 65 is equal to 115. This angle right here is 115 degrees, and so that would be 180 degrees minus 65 degrees. Okay, we're going to use that down here. So 115. Okay, now, again, I know that because, remember, these two angles add up to a straight line, basically, and from there all the way to there, that's a 180 degree rotation. Now what I've got is I've got enough information to figure out what this angle is up here, because that's going to be 180 degrees minus the 50, minus that 115 that whoops, you can't see that. Sorry, it went right off the screen there. Minus the 115 that I just found. So 180 minus 50 minus 115. Ooh, that little angle up there is just 15 degrees. But now, see what happened here in this triangle? Now I have got this angle and that side, and they are opposite each other. Now what I got to do is I have to come up with a way of finding either the length of this hypotenuse or this hypotenuse. And I tell you what, let's find this length right here. Let's find this x. Okay, actually, I'll give that a different, let's color that red there. So I'm going to find the length of this side right here. Now, in this triangle, to find x, the angle opposite it is actually going to be the 50 right there. Okay. So I know that there's a lot going on. I know that it's kind of busy here, but let's just walk through again really what I did here. I found this angle by subtracting 65 from 180. I found this angle up here by subtracting these two angles from 180. And the reason why that's important is because this is the angle that's opposite the 7.6. So now I can set up 7.6 over the sine of 15 degrees. So I'm still working on this triangle right here. That is going to equal x divided by what's opposite at that there is going to be the sine of 50 degrees. Now I'm set up here. I will cross multiply. So 7.6 times the sine of 50 degrees is going to equal x multiplied by the sine of 15 degrees. I want to get x by itself, so I'm going to divide, okay, by the sine of 15 degrees to get x here. And now it's just calculator work. Okay, so that'll be 7.6 multiplied by the sine of 50 degrees, close the brackets, divided by the sine of 15 degrees, and we get 22.5. Now I'm going to leave this number in here right now, but down here I'm going to write 22.5 meters. I'm not done though, because I still don't know what h is, and that really was my goal. So I'm going to make sure I can see that here, 22.5. Now I'm going to ignore this, and I'm just going to look at this triangle right here. So here's my angle. That helps me identify the h as the opposite side, and I just figured out what x was, and x is the hypotenuse here. So that's the sine ratio. The sine of 65 degrees is going to equal h over 22.5. Okay, now I'm going to treat this, I know that the sine of 65 is a number. In the past, I used the calculator to get that number to 4 decimal places, but now I'm just going to leave it there because I know it's just a number. I will cross multiply. 1 times h is just h, and this will be 22.5 times the sine of 65 degrees. I'm going to let my calculator do that, and I've already got that 22.49 blah, blah, blah in there, so I'm going to multiply that by the sine of 65. And right there, to the nearest tenth, the answer here is going to be 20.4 meters. Okay. So it's a little bit of an involved process here. We got to take the information that we've got to find a part of that right angle triangle that we have here. And then, so we use the sine law to get to that, and then we use that to finish the problem.